In this video, we look at multiplying and distributing radicals. And before we do that, I want to remind you of a few things. The first thing is radicals can combine through multiplication. We've simplified radicals or split radicals before, but you can also combine radicals using multiplication. What I mean by that is if I have an nth root of something like a times another nth root of something like b, I can combine those into a single radical, which is also an nth root of a times b. So radicals can combine through multiplication. Second, when several items are multiplied, we can rearrange them in any order, okay? So what I mean by that is if I have something like A times BC, this is all multiplication. So in fact, I could just write this as A times B times C, or I could rearrange it as B times C times A, or any other order would be fine. And the key is that the original expression is all multiplication. Okay. The third thing is, what people get confused about is we distribute when we have two things multiplied, one of which is a sum, meaning addition, or a difference, meaning subtraction. So, for example, if we come back to this previous example, we don't distribute here because BC is multiplied. So this is not addition or subtraction, okay? So when do you distribute? You distribute if you have something like A times the quantity B plus C. So if I want to multiply A times B plus C, I distribute my A because I have my plus here inside, and that gives me AB plus AC. Similarly, if I have something like A plus B times C plus D, I still distribute, but I distribute my A to my C and my D to get AC plus AD, and then I distribute my B to my C and my D to get plus BC plus BD. So there are the things I want to remind you of before we get into multiplying and distributing radicals. The big thing here is understanding the difference between when you distribute and when you don't distribute. If it's all multiplication, you don't distribute. You just multiply in whatever order you want. If you have multiplication next to things added like this, if you're multiplying by a sum, you distribute. Okay, so let's see some examples now. So simplify. Assume variables represent positive numbers. We have to assume that if we want to avoid the use of absolute values in our answers. The first one I want to look at is 2 square roots of 3 times negative 4 square roots of 6. Notice this is all multiplication. So what that means is I basically have just 4 things multiplied. So this is the same thing as 2 times the square root of 3 times negative 4. Notice I'm putting my negative 4 in parentheses. If I didn't, it would look like subtraction. And then I've got times my square root of 6. And since it's just multiplication, all multiplication, I can rearrange this however I want. So I'll put my 2 times my negative 4 next to each other times my square root of 3 times my square root of 6. And I can multiply this in any order that I want. So what I'm going to do is multiply my 2 times my negative 4 to get negative 8 times. Then I'll multiply my square root of 3 by my square root of 6. And remember, these are both square roots, so I can combine them because they're multiplied to get the square root of 18, because 3 times 6 is 18. So I have negative 8 square roots of 18. Now, I need to simplify, okay? So what that means is whenever I have a radical, I need to see if it will split. And I know I can split 18 using 9 times 2. So that gives me negative 8 times the square root of 9 is 3. Now how do I know it's times right here? Because up here, this is times. I have negative 8 times the radical. So I have negative 8 times the square root of 9, which was my 3, times the square root of 2, which can't be simplified. Now negative 8 times 3 is negative 24, and I have negative 24 square roots of 2. Now, yes, I took a very long approach to this problem, but I'm trying to show all the details here. There are certainly a lot of steps you can skip when you work these problems. Okay, let's look at example 2. Negative 2 times the quantity 3 minus the square root of 6. Now I have a minus in here. That means I have to distribute my negative 2. So I get negative 2 times 3 is negative 6. Negative 2 times the negative square root of 6 is positive, because a negative times a negative is positive. I can't multiply 2 by 6, because 6 is under a square root and 2 is not. So I simply have 2 times the square root of 6. And there's nothing I can simplify here. I can't add negative 6 and 2 because 2 is multiplied by the square root of 6. And I can't split the square root of 6 into a perfect square and something else. So we're done. Let's look at another. Let's take 11 square roots of m plus 4 square roots of n quantity squared. And remember that don't try to create rules for situations that you're not sure. To square something means to multiply it by itself. Okay? Don't try to create a rule that doesn't work. Instead, just use what you know. And we know that to square something means multiply it by itself. So I have 11 square roots of m plus 4 square roots of n times itself. And now we know we need to distribute. So I'll take and distribute my 11 square roots of m first, which is going to give me 121, 11 times 11. Square root of m times square root of m is square root of m squared. Remember, they combine because they're both square roots, and we're multiplying so they can combine to get m squared. Plus, then I distribute my 11 square root of m to the 4 square root of n, giving me 44 square root of mn. And now I distribute my 4 square roots of n to give me 44 square root of mn again. And I distribute my 4 square root of n to another 4 square root of n, giving me 16 square root of n squared. Now I need to see if I can simplify any of this. And I notice that the square root of m squared is just m, and the square root of n squared is just n. So I have 121m, and on the end I have plus 16n. And in the middle here, I have like terms, like radicals. I have 44 square roots of mn plus another 44 square roots of mn, giving me 88 square roots of mn. I can't simplify anything. I don't have any like terms that I can add. I can't split the square root of mn. There's no perfect squares that I could split out. So this is my final answer. Looks messy, but that's the final answer. Let's look at one more example. Let's say we have 2x plus the square root of 3 times 2x minus the square root of 3. So again, we're going to distribute. 2x times 2x is 4x squared. 2x times negative square root of 3 is negative 2x square root of 3. Then I take square root of 3 times 2x, which is positive 2x square root 3. And square root of 3 times negative square root of 3 is negative square root of 9. So when I look at this, I can see that I can't combine 4x squared with anything. Negative 2x squared root of 3 plus 2x squared root of 3 is 0. And I have minus the square root of 9, but the square root of 9 is 3. So all I do is replace this with 3. And so we end up with 4x squared minus 3. Now, notice that the middle terms canceled. That's because we multiplied what are called conjugates. 2x plus square root of 3 and 2x minus square root of 3 are conjugates. They're the same thing, they just have a sign that's different in the middle. And anytime you multiply conjugates, the middle terms cancel. All right. If you look back at the previous example, it was similar. 11 square root of m plus 4 square root of n. It wasn't multiplied by its conjugate, it was multiplied by itself. So what you saw in the middle here was they didn't cancel. You didn't have a plus and a minus, you had a plus and a plus. When you multiply something by itself, the two terms in the middle will always combine to double. So instead of having 44 of them, you had two 44s, which gave you 88 of them. Okay, so I just want to point out some patterns there. When multiplying a binomial by itself or multiplying a binomial by its conjugate, what exactly happens. But in any case, it's simply distributing, okay? Unless you have no addition or subtraction, like this first example, it was all multiplication, then you can just rearrange it however you want and multiply in whatever order you want.